Good evening, class. We started section 7.2 last time, the second portion of inverse functions. So let's quickly recap what we've done. Of course, some basic trig identities, inverse trigonometric functions. We started by going over the examples, and remember the best course of action is when you are interested in finding the inverse, you remember it represents an arc on an angle. So you start with that. In this example, obviously tan inverse of 1/2 is theta. We are interested in sine theta. In this case, sine inverse of negative 1/3 is theta. We are interested in finding cosine. In this case, cosine inverse of negative 1/3 is theta. We are interested in finding tangent. As far as secant and cosecant and cotangent is concerned, we mentioned that the best course of action to go to the reciprocals, okay? Now, when it comes to cosecant and secant, they follow sine and cosine accordingly, so that works out fine. When it comes to cotangent, however, remember, if you go with tangent, it doesn't work. Why is that? Because in the case of a cotangent, you go from 0 to pi, just like cosine. So if you could somehow change from cotangent to cosine, you can get the correct answer. Otherwise, the process is a little bit different. So as you can see here, when we are dealing with a positive cotangent, if we are in the first quadrant, it works just like a tangent. You can deal with the tangent, okay? But when it's not in the first quadrant, then you are better off to go with the cosine. So I hope everybody remembers the reason for it, and that works for everybody. We used identities to get to this one as an example. That's not the only way. Ultimately, you have a choice, but you got to be comfortable with both methods. So I believe this is the last one we did. So let's go with the next example. So let's just get started here. Okay. The reason I'm stopping the video because, I think it needs, it makes it easier for everybody to see. When I have the video on, it becomes difficult sometimes to, upload this stuff. In any event, so we are looking at number 7. Okay. So number 7, and I hope everybody can see that, we are interested in tan of sine inverse of u. By any method, you can, go through the process. Now, we want to start the easy way out. What is it that we need to know? Well, sine inverse u represents an arc on an angle, let's say theta, which means sine theta is u and tan theta is missing. That's the idea behind this, everybody. Okay? And so, with that being the case, there are a number of ways to do that. You can say tan theta is sine over cosine. Sine is u and cosine is square root of 1 minus u squared. So that is really the fast and easy way to handle it. Okay, so if you replace the cosine with square root of 1 minus sine squared, you come up with the answer. As far as the sine is concerned, that means positive or negative. Remember, tangent and sine, both of them go from negative pi over 2 to pi over 2, so you have nothing to worry about. Okay, I hope that works out for everybody. All right, let's go to the next one. Before we do so, I hope everybody is comfortable with this. I hope everybody is following what happened. Okay. All right. Here's the next one. We are interested in finding tan of secant inverse. So we start with secant inverse. And remember, secant is the same as cosine in essence. By that, I mean it's 1 over cosine. And what matters is to know that it goes from 0 to pi. That's the idea behind that, why I mentioned that. So what is the secant inverse u equal to? Who knows theta, alpha, beta, gamma? You pick an arc. So understand what we really are looking for, tan of theta in essence, given secant theta. So it's really important to understand, in essence, secant theta is given, and we want to go from secant to tangent. That's the idea behind it, okay? So if we want to go with an identity, we have a Pythagorean identity, everybody remembers, right? Can anybody tell me what is that Pythagorean identity, which relates secant theta and tan theta? That's one of those fundamental identities. Anybody remembers that formula, class?
The one that involves secant and which other?
Tangent.
That's going to be tangent square theta plus 1 equals secant square theta.
Beautiful, beautiful, beautiful. Okay, so if that is the case, we are practically done. We just replace it, you know, whatever is given. Okay. So tan squared is secant squared minus 1, and then it becomes u squared minus 1. That is the answer, because secant theta, we said it's u. Okay. And so tan squared is u squared minus 1, and tan theta is square root of u squared minus 1. All right. So let's look at the last one. Make sure your audio is muted. All right, I want to give everybody a moment to think about this in the same manner, okay, to see what you can come up with. All right. Anybody has the answer for us? What are we looking for, class? Sine inverse is like theta. So you want cosine of theta given sine theta equals to u. If sine theta is given as u, what is cosine? That's a simple Pythagorean identity. Okay, class? So that would be the answer. I hope everybody's okay with that. All right. So we're done with this section, class, inverse trig functions, and we needed this to be able to do the next section. All right. We are looking at section 7.3, everybody. So now we are going to look at trigonometric equations. Again, going over some of the old stuff, a lot of identities that we have dealt with. Hopefully we remember them. It is extremely essential that we be comfortable with those to move on. The concept of an inverse function. And now using that, we can solve equations. We're going to start with the same method as we did with basic algebra. First, the solution. If you recall, solution, we mean something that makes the statement a true statement. So with that being the case, the question is, determine whether theta equals pi over 4 is a solution for this equation. So what do you think we should do, class, then? We should simply do what?
Solve for theta.
Just plug in. We don't have to solve for anything. Come on, it's asking, is this a solution? If it's not, if the solution is not given, then you have to solve it. But just the way it is pi over 4 a solution? I don't know. Let me plug in. So when we plug in, we get 2 sine pi over 4 plus square root of 2. What is sine of pi over 4, class? So you see the importance of knowing the basics, okay? The common arcs, all the trigonometric functions, and so it can go nice and smooth.
2 over 2.
Sine and cosine are square root of 2 over 2 when theta is pi over 4. And so we can cancel out the 2, we get square root of 2 plus square root of 2, and that is not equal to 0. Therefore, pi over 4 is not a solution. Very good. Okay, so it's not a solution, everybody. You want to make a note of it. This is not a solution. Okay. So what do? Now we are checking for 5 pi over 4. So pi over 4 is out. No, it's not good. Okay. So all you have to do, figure out what sine of 5 pi over 4 and put it in. And I hope you see and you recognize immediately that your reference arc is pi over 4, which means, numerically speaking, sine of 5 pi over 4 and sine of pi over 4 are the same. It is just positive, negative you have to figure out. So I hope you see. Okay, if this is theta, then the reference arc is pi over 4, which means the same answer, square root of 2 over 2, but we don't know if it's positive or negative yet. We got to figure out based on the quadrant. So 5 pi over 4, which quadrant is that, everybody?
Third.
Third quadrant. Class, remember, whatever the denominator is, if you make the numerator like that, so 4 pi over 4, that means pi. Okay, so 5 pi over 4 is larger than that. Puts us in the third quadrant. In the third quadrant, sine is positive or negative?
Negative.
Therefore, you plug in and it gives you 0 and it works out and you're done. Does that make sense? Is everybody okay with that? Okay. So that was a case where we are given some solutions to check. A true statement means yes, it is a solution. A false statement means no, it's not. And so this is the case here. Sounds good? Any questions, class? Very straightforward. Just plug in, make sure you're very comfortable with your common arcs, trigonometric functions of common arcs angles, okay? Here's the next one. Now we want to solve. When we want to solve, either the question is just solve from 2, or it may ask to find all solutions, okay? So, in order to solve this, this is a very simple example. First, we move the -3 becomes positive on the other side, we divide by 2. So this is our algebraic step. Move -3, divide by 2. All right. To answer this, let's first answer this from 0 to 2 pi, everybody. 0 to 2 pi. So cosine theta is equal to square root of 3 over 2. First, let's go with the first quadrant and the reference arc, if you will. Theta equals what? Go ahead.
Pi
Beautiful.
over 6.
Beautiful. Pi over 6 is the answer.
Quadrant 1.
And then we have one more. Go ahead. We have one more. So pi over 6, and therefore pi over 6 is your reference arc. Cosine is positive in the first quadrant, pi over 6. Also in which quadrant?
Cosine is. I'm sorry. Can you repeat the question? What exactly?
Cosine is positive in 2 quadrants. Which ones are those? Besides the first one, there is one more.
The second quadrant.
No, the second quadrant sine is positive. It is the fourth quadrant.
Fourth one, sorry.
Okay, good. And so the answers are, notice what the answer will be again. Not only this is an answer, let me use the color properly. Not only this is the answer, it is also the reference arc. Okay, how do you come up with that? Since it's in the fourth, okay, can't believe this is not doing the job. It's in the fourth quadrant also, then all you have to do 2 pi minus pi over 6. So this would be the second one from 0 to pi. Now, if we want from 0 to 2 pi, we are done. But if the question is find all solutions, then all you have to do add 2n pi or 2k pi, where n or k are both integers. Is everybody following that? Is there any questions? Okay, now, it is extremely important that you be comfortable with common arcs. It is extremely important that you be comfortable with the quadrants, okay? And to me, the easiest way is this. Cosine is like x, first and fourth quadrant positive, okay? Sine is like y, and I don't want to say it is equal to y. It becomes equal to y if you're dealing with a unit circle, but not necessarily we deal with the unit circle. So it's like y, and that's positive in the first and second quadrant, and everything else follows accordingly. All right, let's give everybody a minute. I'm going to pause the recording. I want to give you 1 minute. See if you can figure this out. It's really not a big deal, class. All right, so it's very straightforward. You solve for sine x, you get 1/2. So theta is equal to what?
Pi over 6 and 5 pi over 6.
Beautiful. And again, you would be done if the question was asking for what? 0 to 2 pi. It's asking for all solutions. You add up 2k pi or 2n pi. Remember, 2k pi or 2n pi, and as you do your homework, whatever that mom, my open math is using, you stick with that. K or N, they are integers. All right, we're gonna move on. Any questions so far? All right. We are looking at this question, square root of 3 tan 3 theta plus 1 is equal to 0. We are interested in the answer from 0 to 2 pi. All right. The trick is whenever you have multiple angles is to write the general solution. And then from 0 to 2 pi, you decide what's the answer. And I'll show you the method. So first and foremost, you just solve for it. That means you take the 1 to the other side, divide by 3, square root of 3. So this is very straightforward. This is a basic algebraic step. So far, so good. Now, from 0 to 2 pi, tangent is negative square root of 3 over 3. So you can ignore the negative. Let's discuss the positive and see what is the reference arc. If it were positive, okay, again, I want to make sure everybody understands how I approach that. First, look at this one without the negative. That gives us what is called the reference arc. So if it were square root of 3 over 3, theta would be what? What would be the reference arc? Anybody can help us? Okay, Houston, we got a problem. Not many people are comfortable with the basics, meaning common arcs. Okay, so the answer is pi over 6. That would be the reference arc. However, the question is asking for negative square root of 3 over 3. So we want to see where tangent is negative. Tangent is negative in which quadrants? Tangent is negative
Second and fourth.
in the second quadrant
Third and fourth.
And fourth.
and the fourth. Remember, it's positive in the first and third.
Third.
So now we want to get the answer in the second quadrant. All you have to do for the second quadrant, say pi minus pi over 6. Is everybody with me? For the second quadrant, this is how the reference arc is used, okay? For the second quadrant, let me actually do this. Let me erase this and put it a little bit further. So first, so this is quadrant 4. Now, for quadrant 2, you would say pi minus the reference arc. Okay. For quadrant 4, you would say what? 2 pi minus pi over 6. That's how you arrive at it. And so those are the answers. Okay. But it is not theta, it's 3 theta that is equal to that. Okay. So how do you handle that? Okay, that's extremely important to know when you have multiple angles, how you do that. Okay, it's a little bit different. So you add 2k pi if you're dealing with sine and cosine or secant and cosecant. But in the case of a tangent, what do you add up? It is n pi. Remember the period is pi. So you're going to add n pi. I hope everybody's following so far. So 3 theta is 5 pi over 6 plus n pi, 11 pi over 6 plus n pi, and we are going to divide by what? We are going to divide by 3, everybody, right? Because we are not interested in 3 theta. We want to find theta. And so when you divide, what do you get? You divide both sides by number 3. Okay? You get theta equals 5 pi over 18 plus n pi divided by 3. Theta equals 11 pi over 18 plus n pi over 3. Now, is everybody okay up to here? Assuming the question was asking for a general solution, you're done. But that's not the case. The question is asking from 0 to 2 pi. So I want to show you how you arrive at all answers without missing one. If you do not go this route, if you do not put the n pi and then divide by 3, whatever the coefficient of theta is, you will not get to all of them. Okay? So now, starting with the first one, okay? You start plugging in 0, 1, and 2 into each one. Okay. And so when you do that, notice what happens. If you go this route, 5 pi, okay, and you plug in 0, 1, 2, you get all the answers. Okay, I want to make sure that everybody knows what we're talking about here, so let me just get rid of this. I want to explain to you why 0, 1, 2, and why do we stop at that, okay? Just for the sake of argument, I want you to know that you really have 2 choices. I want to make sure everybody understand that. If you go with 0, 1, 2 for each one, 0, 1, 2 for each one, you get to the answer. If you choose the smaller of the 2, you have to go all the way to number 5. Okay, so let me just erase this and I want to explain this one more time. But you don't want to take a chance, class, especially if it's sine and cosine. Instead of going all the way to 5 using the smaller of the 2, go to 2, okay, 0, 1, 2. For the smaller one, 0, 1, 2 for the larger one. I want you to know what happens if you pick a larger number for each case, especially for the larger one. If you pick n equals 3 and you plug it into this, I hope you see that what you get. You get 3 times pi over 3, so you're adding another pi, and it will go beyond, okay, the number that you are interested in. Okay, class? So that's important to understand. So you have 2 choices. You use 0, 1, 2, 3, 4, 5 for the smaller one, or you use 0, 1, 2 for each one. Let me just put a different color and everybody understands what I'm doing here. This one, you put 0, 1, 2. This one, you put 0, 1, 2, and you can try it, and this is your answer, class. In the case of a sine and cosine, secant and cosecant, you must go that route. In the case of a tangent and cotangent, because the period is only pi, you can go with the smaller of the 2 and put all 6. Starting with 0 all the way to 5. Okay. Why 5? because 2 times 3 is 6 minus 1. That's why. But the better approach, in my opinion, is to use 0, 1, 2 for each cases. Okay?
So just so I'm clear, I did the math real quick. 5 pi over 18, 11 pi over 18, 17 pi over 18.
Okay, I lost your voice. What happened?
Can you hear me?
Yes, go ahead, please.
Sorry, I accidentally muted it when I was speaking. So I did the math. It adds up if n equals 1 or 2 or 0 respectively. That does give you 5 pi over 18, 11 pi over 18, 17, yada yada. So if we were to continue, you're saying, well, try to stop at 0, 1, 2. There's no need to go 23, 29, 35. Correct?
No. Okay, yeah, I want to make sure you understand. If you want to use both of them, 0, 1, 2 for each case, do you see the top one? Okay, again, look at this one. Use 0, 1, 2 for this one, use 0, 1, 2 for this one. Or smaller of the two is the top one. You can use 0, 1, 2, 3, 4, 5. Is this clear? And you can only do that for tangent, cotangent. So my suggestion is that you stick with 0, 1, 2 for each case, just to be on the safe side. But here's what happens if you pick a larger one, or even right here after number 5, if you go ahead and pick number 6, then you're going to go beyond this 2 pi class. If you pick a number larger than 5, it will go beyond the 2 pi. Do we understand that? Because if you put the 6 here.
Professor.
Yes. You get 6 pi over 3, which is 2 pi. Go ahead, I'm listening.
Sorry, isn't 3 the same thing as going beyond 2 pi?
No, it's because it's pi. Do you see that? If it were sine and cosine, then you would have 2n pi, and therefore, right then and there, the 3 will go away. That's why I'm saying I would highly recommend you stick with 0, 1, 2 for each case, rather than 0 all the way to 5 for the smaller of the two.
Oh, I see. You're recommending that equation, 5 pi over 6 plus n pi, instead of the n pi over 3.
Yes, I'm recommending that you use both of them. Let me use
I think
this
it'd be
color
good
now.
if you take your mouse and you circle which one you recommend, because I think
Class.
that's a little, you went back and forth.
This one, everybody can see the one in green?
Yes.
Okay.
Yeah.
The top one reads 5 pi over 18 plus n pi over 3, yes?
Yeah.
And the bottom one reads 11 pi over 18 plus n pi over 3, right?
Yeah.
Use both of them. And in each case, just use 0, 1, 2. Why is it that I want you to do that? Because in the case of a sine and cosine, you have no choice. Okay, class? In the case of a sine and cosine, you have no choice but to do this. For the case of a tangent and cotangent, you do have a choice, but don't mix them up. Stick with this one, because this works for all of them. Does that answer the question?
Yeah, that makes sense.
Okay, ignore this. Okay, let's just clean everything up, okay, Class, the one in green, those are the questions, those are the answers we came up with, right?
Yeah.
Use 0, 1, 2. Okay, let's say, I want to make sure everyone understands when we stop. Let's say instead of 3 theta, we had 5 theta. Then we would go 0, 1, 2, 3, 4. We stop at 5. We don't go to 5. I think we've taken care of the business. Is that clear?
Yes, thank you.
Sure. Towards the end, if there is, if we don't have a similar question, I give you a similar question. We discuss that. Let's just quickly finish this, and then I'll make up a question. We go over that. Here's the next one. Cosine of theta minus pi over 4 equals 1, and we are interested in the answer between 0 and 2 pi. Okay, so let's see the process involved. Never mind that it says theta minus pi over 4. You can think of this class as, I don't know, let's say alpha. Cosine alpha is 1. How about that? Okay. If cosine alpha is 1, alpha must be what? Between 0 and 2 pi. Anybody? When is cosine equal to 1? Remember the quadrantal angles. Remember cosine represents what? Okay.
0.
Very good. So alpha is equal to 0. That means theta minus pi over 4 is 0. Therefore, theta is pi over 4. And there's only one answer simply because in the interval of 0 to 2 pi, cosine is equal to 1 only once. By the way, notice theta is between 0 and 2 pi. 0 is included? Yes. 2 pi is included? No. Why not? Because 2 pi really in essence means the same as 0, right? That's why we don't want to go from 0 to 2 pi, inclusively for both of them. Actually, the question I was looking for, we have it right here. Sine 2 theta equals 1/2. Why don't we do that? Why don't we give everybody a minute to think about this question and see if you can do it with the method that I explained, okay? And we take it from there. So let's pause the recording for a moment. All right. Now, this is a very straightforward question, okay? And we know that, never mind that it says 2 theta, you can think of it as alpha, beta, gamma. The answer, sine is equal to 1/2. What's the answer? There are two of it. Okay, class, I can't hear you. Anybody want to share with us their answer? Okay. Houston, we got a problem again or no? Hopefully we don't have any problem. Okay, sine is equal to 1/2 at pi over 6. And then the second quadrant is positive pi minus pi over 6. All right, class? Is everybody okay with that? Remember, if we want all solutions, we add 2k pi. We divide, remember 2k pi, 2n pi. We divide by 2. If we want all solutions, class, we are done. Right here, this is the final answer. Okay? We are done. But if we want it from 0 to 2 pi, we are going to replace the k with what? In each case, class, we are going to replace it with okay, I can't hear anybody unless, okay, everybody can hear me, right?
Yes.
Yes.
Anybody want to answer it? We're going to replace the k with what? Okay. Class, this is number 2. So you're going to replace it with 0, 1, but not 2. Why not 2? Replace it with 2. Becomes pi over 12 plus 2 pi. It's beyond the 2 pi. Do you follow what I'm saying, everybody? So we replace it with 0 and 1. In general, we replace it all the way to n minus 1 if it's sine n theta. I wrote that for you here. And so therefore, the answer is if you replace k with 0 and 1 for the first one, you get pi over 12, okay, and 13 pi over 12, okay. So 0, 1, put it in here. It results in this case and in this case. Do you follow what I'm saying? And then if you put it into the second one, it gives you the other two solutions. Any questions?
Professor,
Everybody?
the n minus 1, is that only applicable for sine n theta, or is that for any of the other?
For any multiple angles, as I said, anytime you're dealing with multiple angles, this is the methodology class. When you're dealing with tangent and cotangent only, you have a different option. In my opinion, don't use that because you don't want to mix things up. Always use this option. I hope everybody can see. If I use 2, it goes beyond 2 pi. Do you see that, everybody? Right, class?
Yes.
So I hope you see why we do not use the n, the coefficient of theta. Okay? We use everything less than that, starting from 0 all the way. All right, so that was actually a question I had in mind. It covers the thing that I wanted to mention. Let's go to the next example before we do so. Questions? Everybody's okay with this?
On the exam, if you asked for just the general answers or like the two equations, would you want us to write both equations, or is just the first one theta equals pi over 12 plus k pi fine?
Okay, if you wrote the first one, you have answered half of the question. It is incorrect.
Okay.
Okay, I'm glad you asked that question. That was a great question. Everybody, if the question is asking for a general solution, okay, you didn't see that. This is done, okay? You must answer both of them. You must answer both, not one, both. Why is that? Replace the k with any number you want. There is no way for you to get to the second and the fourth answer. Do you see that, everybody? Replace the k with any number in your mind. You will never get to the second and the fourth answer. Therefore, you need both of them. All right, we're going to go to the next question. Sounds good? Everybody? All right.
Yes.
All right, let's look at questions that are somewhat different, okay? Two cosine squared minus cosine theta minus 1. Do you have to replace the cosine with something such as a, b, x, y, z to realize you're dealing with a quadratic equation? It's your choice. If it helps, let cosine theta be x, for example, and you're dealing with, okay, if you let this one be x, then you're dealing with 2x squared minus x minus 1 equal to 0. You know how to factor this. Do you have to do it to recognize it? It's your choice. If it helps, by all means. If you don't need to, just do the factoring here. And I hope everybody remembers how we do the factoring. It's a very simple case. If it doesn't work, you have to go with the quadratic formula. So it's 2 cosine theta plus 1 times cosine theta minus 1 equals 0. Sounds good? And so we want the answers from 0 to 2 pi. In each case, we figure out what we need to do. So we set the first one equal to 0, gives us cosine theta equals negative 1/2. Second one equal to 0, cosine theta equals 1. So first, factor out. Then set each one equal to 0 and solve each case. Now cosine theta equals negative 1/2. So that's what we want to answer. To answer that, you can ignore the negative 1/2. I want to again make sure everybody understands how we arrive at the answer using the reference arc. So if the question was saying cosine is 1/2, okay, because this way I can get the reference arc. What is my reference arc? Can anybody tell me? Cosine equals 1/2. What's the answer? Okay, Houston, we do have a problem. Pi over 3. Pi over 3. Okay, so now that it's negative 1/2, the answer is not pi over 3. Remember, this is a reference arc. Cosine is negative in which quadrants, class?
Second.
Quadrant 2 and
Third.
Third.
therefore, in quadrant 2,
2 pi over 3.
very good. Pi minus pi over 3. In quadrant 3, pi plus pi over 3. Very good. Is everybody okay with that so far? And obviously everybody remembers cosine theta equals 1. The answer is, what is the answer? Okay, 0. So those are your answers. You can leave it like that. You're done. Or if you want to put them in braces and represented in this manner, it's absolutely up to you. Is everybody okay with this? Is there any questions? Now, I hope everybody can see what we are doing here. We are just drilling. You gotta get comfortable with the quadrants, with common arcs, remembering all of the above to be able to move on. Otherwise, it becomes really tedious, okay? All right. We are going to go to the next one. Any questions, class? Everybody is ready to move on? Okay, I think we are good to go. Okay. All right. What happens when we are dealing with a case where different trigonometric functions are involved? In that case, normally we need to do some sort of adjustment. By that I mean we have to use some identity that will help us figure out what we need to do. Okay. So what identity do we need here? Let's look at what is given and what identity can help us. If you look at the left side, you have sine squared and sine. If you look at the right side, you have cosine squared. So maybe because on the left side, both of them are sine, on the right side, it makes sense to change it to sine. You follow what I'm saying? Okay. If for the sake of argument, two of them were cosine, maybe the sine squared, then you want to change it. So the left side, we don't touch it. The right side, we want to change the cosine squared. So what is the identity that we can use? We can use what? We want to replace cosine squared. We replace
Sine
it with?
square minus cosine square equal 1.
So 1 minus sine squared, right? Because
Yeah.
sine squared plus cosine squared is 1. Absolutely correct. We bring everything to the same side and we put it in descending order. I hope you see that we are doing algebraic techniques here. So we get 2 sine squared minus sine theta minus 1 equals 0. And it's practically the same factoring as before, as the previous page. Again, you can do the factoring just the way it is, or you can say 2x squared minus x minus 1 equal to 0. Whatever that makes life easier for you for the sake of factoring, that's fine with me. This is practically the same as before. And so the factoring gives us this. So sine is either negative 1/2 or 1. Can you figure out the answers, class? So what are the answers? Sine theta, if you go with 1/2 as the reference arc, that gives you pi over 6. So sine theta equals 1/2, the reference arc. Okay, let me write all of them. Theta hat, theta prime, theta sub r is, I'm refreshing your memory about how we write the reference arc. There are different ways of representing them. So that is the reference arc. Sine is negative in which quadrants, everybody?
3 and 4.
Therefore, in the case of a 3, you add pi to this. In the case of a quadrant 4, you say 2 pi minus pi over 6. I want to make sure. So in quadrant 3, we would say pi plus pi over 6. In quadrant 4, we would say 2 pi minus pi over 6. We have the answer. Sine theta equals 1. When would that be? You should know that. Theta equals? Okay, pi over 2. So these are the answers. There is one more question in this section. Rather than taking a break, let's finish that and then we take a few minutes of break, class. Again, I really don't know what to tell you. You've got to get comfortable with all of this, class. You need it for the next course. You can't be uncomfortable with common arcs. It's going to be very difficult to move on, okay, and use this in the next course. I want to go to the last example before I do that. Any questions?
No.
All right. So again, common arcs, okay, reference arcs, and how we arrive at the answer using the reference arcs. Everything has been discussed, and I've gone over that a number of times to make you comfortable with that. Here's the last question. You don't have anything except on one side is sine squared, on one side is cosine squared. So as long as you change one of them is good enough, okay? It doesn't matter which one you change. However, because the left side has 3 sine squared, it's easier not to touch that and change the right side to 1 minus sine squared. That's the only reason. You could change the left side, but it's easier this way. And so now it's a very easy case. We move the negative sine squared and we end up with 4 sine squared equals 1, which means sine squared must be equal to what? 1/4, right, class? 1/4. So what is sine theta? Sine theta equals, anybody?
1/2.
Plus or minus half.
Plus minus 1/2. Plus minus 1/2, everybody. That makes sense? Now, for 1/2, you know the answer. For negative 1/2, you know the answer. Remember, for 1/2, the reference arc was pi over 6. Okay? And so take it from there. I'm assuming everybody can see how we arrive at the rest of it. So these are all your answers. All right, class. This brings us to the next section, section 7.4. Trigonometric identities. What we have done so far, we've dealt with some basic identities. Known as Pythagorean identities, reciprocal identities, even and odd properties, inverse sine functions. We did some equations, and now we are going to look at identities and how we deal with them. Okay, so this is reminding you of what we have seen. And in order to establish new identities, we use the information from the past to prove the new stuff. So, and the concept that two functions f and g are identically equal if f and g equal, f is equal to g, okay, this is an identity. For example, tangent is sine over cosine. Cotangent is cosine over sine. And the rest of them, cosecant is 1 over sine. The Pythagorean identities, there are 3 of them. The even and odd identities, every trigonometric function is odd with the exception of cosine. And remember, cosine and secant go together because secant is 1 over cosine. And we really need to know that. To establish identity in the beginning, we may try to use just sine and cosine, and then we may develop other tools and rules. So let's start with a couple of very simple examples. The first one says, simplify tan over secant. Now, even if it doesn't say how to do it, generally speaking, when you have no choice, when you have no idea what to do, go back to the basics. Everything in terms of sine and cosine, and normally they can give us some answer. So tangent theta, we can write it as what?
Sine over cosine.
Beautiful. Secant theta, we can write it as?
In most basic form, 1 over cosine. Theta.
Beautiful, Kamal. That's all. If this is the case, we can obviously drop the cosine.
Sine.
And the final answer is sine. And that's it, class. So the answer is sine theta. Does that make sense? Is everybody okay with that? Now, the second one, I want to really discuss that with two different methods. The second method that I'm going to go over in a moment, not everybody is too crazy about it, but that's fine with me. As far as proving it, especially with mom by open math, you may have to stick with this first method. When you want to establish an identity, normally you have to start with one side and you get to the other. In this case, they're even giving us a hint. So we are going to start with the left side and we're going to multiply the top and the bottom by the same thing. In this case is 1 minus cosine theta. So what happens?
Does the bottom become sine?
Very good. So the top is sine theta times 1 minus cosine theta, but the bottom is 1 minus cosine squared, right? Which is sine squared. Does that make sense to everybody? So now sine theta from the numerator goes away,
Oh, sine.
and in the denominator becomes simply sine theta. Does that make sense? Is everybody okay with that? Now, this is how you establish an identity. If you were doing it in class, if you were doing, exam, and it was for me, and now we have to set it up through mom, I would accept a different method, and I'm going to show you that different method quickly. If you happen to have two fractions, two ratios that are equal, you can always do the cross product. So I want you to see, let me use a different color here. That if you did this one, if you multiply these two, you get 1 plus cosine theta times 1 minus cosine theta. If you, let me use a different color. So we are looking at cross product. If you multiply these two, you get sine squared, don't you?
1 minus cosine squared equals sine.
No.
Yeah.
This is a cross product. Is the left side equal to the right side? The left side is 1 minus cosine squared, which is equal to sine squared. So that is another way of establishing it. As far as I'm concerned, that's absolutely fine with me. And it's normally faster. But my judgment is very simple. Cross product should work. If there is a true proportion, then the cross product must stand. And therefore, this is an absolutely perfect way to prove it. But most of the time, they want you to go from one side to the other. Here's another example that we're going to use a similar technique. Everybody okay with this? As far as I'm concerned, this can establish it by rewriting the left side. Let me use the same color for the left side. The left side is 1 minus cosine squared, and yes, it is equal to sine squared. Okay, class? So as far as I'm concerned, that's absolutely perfect. But in any event, let's go to the next one. In this example class, again, we're going to use the same technique. We go from one side to the other, and really it doesn't matter. Generally speaking, if both sides seem to be almost the same in par when it comes to being difficult and complicated, it doesn't matter which way you start. Other than that, you start with the more complicated side. So in this case, if you start from the left side and you notice the denominator is 1 minus sine theta, so perhaps the technique, just as the previous page, would be to multiply by 1 plus sine theta, the top and the bottom. And we basically get to the same concept. The denominator changes to 1 minus sine squared. Which is the same as cosine squared. So the cosine in the numerator goes away. In the denominator, cosine squared changes to cosine theta. And as I mentioned in the previous page, you can establish this by the cross product, as far as I'm concerned. Okay, class? But this is the same method as the previous example. We're going to move on. Everybody is okay with this? Is there any questions?
No.
Perfect. Okay, let's start with the first one. Even if it's not mentioned that you need to use LCD, the least common denominator, to do the math, I hope it is clear. To simplify this, the process is the LCD. So why don't we do that? Why don't we give everybody a minute? See if you can figure this out by taking a common denominator on your own and see what you get. Well, anyone has their final answer?
For the
Top one, A.
top one, I got 2 over cosine square u.
Beautiful. So you take a common denominator. You're putting them together. The numerator changes to 2. The denominator changes to cosine squared, which is the same as 2 secant squared u. Okay, 2 secant squared u. Just for the sake of argument, so you see how it works. Most likely, both answers are acceptable. If you are doing it for the exam, you can show your work. This is how. Okay, again, I'm going to discuss the exam and the practice test. There's questions at the end that I want to go over, and you see that with your show work, I can look at what if you need a partial credit. The second one, even if it doesn't say factoring, I hope you recognize that would be the case because there is really no other way. The top can be easily factored because it's really a squared minus b squared. That's why you got to be extremely comfortable with your factoring. The top is a squared minus b squared, which is a minus b, a plus b in any order. And the bottom, you simply take the sign out as a common factor. So I hope everybody understands what we are talking about here. A squared minus b squared. 1 is the same as 1 squared or 1 cubed or you name it. Okay, everybody? And so you can drop the common factor and you get 1 minus cosine over sine. You can rewrite this as 2 fractions. Okay, class? And therefore, all you have to do, rewrite the last step. Is that making sense? Everybody? Which is cosecant minus cotangent. All right, I hope everybody is following this and is okay with everybody. So we can move on. Sounds good, class? We are drilling and you really have to go back and spend some time on these questions. This was a really nice example. It covered a lot of bases, okay? So we're gonna do more. this works out in the same manner. We have to do the LCD to figure out what needs to be done. So why don't we give everybody a chance to work on this for the next couple of minutes. What is the technique? LCD, the least common denominator. All right, you take a common denominator, so you get 1 plus sine u times cosine u plus cotangent u minus cosine u times sine u over the sine u cosine u. So that is the common denominator. Okay, I hope everybody has done that. So basically, you are going to multiply and you keep the common denominator as sine u, cosine u in any order you want. So the first one becomes cosine u plus sine u cosine u, and the second one becomes cotangent u sine u minus cosine u sine u. So that's a very straightforward process, okay? Now, sine u cosine u minus cosine u sine u, they cancel each other. So we end up with the rest of it. Cotangent is the same as cosine over sine. So when we multiply cosine u over sine u by sine u, the sine u drops. I hope everybody can see what happens here. So you end up with cosine u plus cosine u, and that means 2 cosine u over sine u cosine u. You get rid of the cosine, and 2 over sine u becomes a secant class. So 2 secant u. Sounds good? Is everybody okay with that? Any questions, class? Sadly, the order wasn't the way I liked it, but I hope everybody has followed and understood what we do. The technique, LCD, the least common denominator, just as the previous page. And now part B, just as the previous page, requires factoring class. You have enough practice by now with the factoring. See if you can figure this out. It really has a couple of simple steps, everybody. It's really not a big deal. So just do the factoring and you're practically done. We are simplifying the trigonometric expressions. When we factor the top again, it's a squared minus b squared. And the bottom tangent is in common. So sine v plus 1, sine v minus 1, and we drop the common factor of sine v minus 1. At this point, class, there is really not much you want to do to simplify. If you want, obviously tangent is sine over cosine, okay? If you make up two fractions, it can make something happen, okay? But whether you want to do that or not, that is up to you. We can continue on that thoughts if you want to see what happens. So if we wrote this as, let's see, I'm gonna write it here, sine V over tan V plus 1 over tan V. In other words, if you go from here to here, you can do that, and you can establish one by one. Sine V over tan V. Let's see if we can simplify that. In other words, that's okay. Do we have to go further? Let's see what happens. Sine V over. Now, tangent is sine over cosine plus 1 over tan V. And now let me use a different color for that, class, because I want to finalize this. Now, what is this one equal to? Okay, this is a complex fraction. I hope you see that it simplifies to cosine, am I right? Cosine V. 1 over tangent is cotangent V. Okay, class? So we can rewrite it in this format if you want. And this is one way to take care of the business. Okay. We're going to go to the next question. Everybody followed what happened. You could leave it as that, but in this case, you can also continue. I would say continuation makes it easier, makes it a more simplified trigonometric expression. So let's look at the next one and see the difference between the two, okay, class? So in the next example, assuming we are okay and done with this, everybody? So
Yes.
Sir, I
now
have
the
one
difference,
question, one brief question.
yes. You want me to bring it back? Okay, go
Yes,
ahead.
please. On letter A, towards the right side, you have that cotangent got replaced by cosecant over cosine over sine.
Yeah,
Then you eliminated the sine with sine, even.
this is, okay, I'm gonna write this. Cosine U over sine U times sine U. Correct? Yes or no?
Yep, got it. Thank you.
Sure. Class, if you have a question, please ask. When you ask, you help everybody. Trust me. Because if you have a question, you're not alone. I guarantee you that. You're not alone. Okay? So do me a favor and do everybody a favor and ask your questions always. I really appreciate that. Okay. Here's the next one, and I want you to see the difference. In this case, we are simplifying trigonometric expressions. In this case, we are establishing identities. So what is the difference? Previous case, we may not know how far we have to go to simplify, but now we should. So what I'd like you to do is to establish this identity. Generally speaking, how do you do that? You start with the more complicated side. So in this case, and sometimes I use this LHS standing for left hand side. As you can see, the left hand side is more complicated. Therefore, use the left hand side to get to the right. Go ahead and do that. All right, so the left side, we are going to replace the cotangent with cosine over sine and tangent with sine over cosine. Okay. So we have sine theta, cosine theta as the common denominator. And cosine squared plus sine squared as the numerator. So let me actually write those. Okay, so sine squared. So we have sine theta. This is cosine squared plus sine squared over sine cosine. Right, everybody? Cosine squared and sine squared is equal to 1.
A little flabbergasted that you took that portion to the other side.
Sine theta and sine theta cancel each other. And the answer is 1 over cosine theta. And that is secant theta. Okay, class? Sounds good. Everybody is okay with that?
Yeah, my initial reaction was to take the sine and divide it to the other side, and I just kept getting stuck. So this makes much more sense why you did this.
Now, as I mentioned, you always want to look, take the side that is more complicated and work with it. And generally speaking, tangent and cotangent, we want to change it to, what do you call it? Establish sine and cosine with it. Okay, as long as you do that, it almost always works. Okay, class? So that's that. All right, so we want to move on to the next question. Everybody okay with this? Any questions? The setup that was given sadly wasn't just the way I expected. That's why I wanted to go over that myself. Okay. And so we are ready for the next example, I believe. There was something missing there over here. You end up with the same answer, but I'm not too crazy about the method. You want to ignore that. The way I wrote it for you, it's faster. Okay. Now we are looking at this example. We want to establish the identity. Okay. And so we want to show that cosecant theta minus cotangent theta is equal to sine theta over 1 plus cosine theta. As I mentioned, there are really different ways sometimes. You can even do the cross product. But generally speaking, as far as establishment is concerned, they either start from one side and they end up with the other, or they start with one side, they bring it to a specific point, and then they work on the other side and they bring it to the same point. This is another way that the identity is established. I want to make sure everybody understood what I'm saying. You can work on the left side and you may not get to the right and you stop it where you think you are stuck. And then you work on the right side and you try to bring it to the same point. As far as I'm concerned, as I said, the cross product will always do that for me, okay? But anyways, let's stick with one side going to the other. As you can see, the left side is cosecant and cotangent, okay, class? So we can write it as 1 over sine minus cosine over sine. And of course, common denominator is already there. Now, we had a case like that before, okay? In order to make this one look like the right side, we did a trick. And you may remember that if you go back a couple of questions, a couple of examples, okay? And the trick was you multiply by the conjugate of the numerator. The conjugate of the numerator is 1 plus cosine theta. And of course, you divide by. So that's why I put it in a different color so we can see what happens. And so with that being the case, we are practically done because the numerator is just 1 minus cosine squared. And everybody knows 1 minus cosine squared is the same as sine squared. And it can cancel out the sign in the denominator and establish the right side, as you can see. Sounds good? Everybody okay with that?
I have a question.
Yes, of course.
How would I know not to stop at 1 minus cosine theta over sine theta?
Okay, it's very simple. If you look at this one, is this the same as the right-hand side? Because this is your left-hand side. You stop and it looks like a right-hand side. Or you stop and you work on the right-hand side. Now you work on the right-hand side and you bring it to this equation, this statement you just established. In other words, you could now work on this one and make it look like this one. But when do you stop? In the left and right, they are identical. That's the way you establish identity. Does that make sense? Everybody is okay with that?
It doesn't matter if we go from right to left or left to right.
No, it doesn't matter. Normally we start with the more complicated one. Okay? Normally we start with the more complicated one. Okay? Sounds good? Everybody?
Yeah.
All right. Okay. We're going to go to the next example class. Are we ready for it? I take it as yes. Number 7. Now, I want to give everybody a moment to do this on their own. But before I do that, can you clearly see which side is more complicated, class? Left or right?
Left.
Good. So that's where you start. So that's it. That's it. You start with the left, you try to make it look like right. Whenever it becomes identical to the right, that's when you're done. And generally speaking, what do you do with tangent and cotangent? You get rid of them. You make them look like sine and cosine. All right. Couple of minutes, you can do this. Okay, class, we replace the tangent, we are looking at the left-hand side, okay? We keep everything intact, we change this to tan and cotangent accordingly, okay? We are looking at a complex fraction. We want to simplify the complex fraction. The best way and the fastest way is to multiply the top and the bottom by LCD. What is the LCD here for the top and the bottom? Anybody can tell me? What is the least common denominator for this complex fraction for the top and the bottom?
Sine and
Cosine theta and sine theta.
Beautiful. So when you multiply by it, here's what happens. You multiply this one by the first one, gives you sine cubed cosine. And then when you multiply it by this one, cosine and cosine cancel each other. You get minus sine squared in the numerator. The denominator works out in the same manner. So I hope everybody is comfortable with changing a complex fraction into a simple fraction. And so finally, all you have to do, factor out the common factor in the numerator as well as the denominator. The top is sine squared. Okay, the bottom is cosine squared, and sine theta cosine theta minus 1, sine theta cosine theta minus 1. So when you do that, obviously the parentheses drop, and you get sine squared over cosine squared. And as you know, sine over cosine is tangent, so this is tan squared. Sounds good? Any questions? I hope you see what we are doing, class. Again, we are just practicing, practicing, practicing. That's all we can do with math. You really need to go over this stuff and get comfortable with it. All right, I want to go over the next one. Any questions? By the way, since it came up, we are doing our homework with mom, my open math. It's nice and easy, decent, to the point. Yes, everybody?
Yes.
Still catching up, but yeah, I'm doing it.
I have a question with the due date. We could talk about that later.
Yes, yes. At the end, we can talk about everything. All right, so here's the next one. Example 8, cotangent squared is equal to cosecant theta minus sine theta over sine theta. So my question to you is very simple. Which side is more complicated?
Right.
So we start from the right side. Does that make sense, class? So we are going to start with the right side, and we want to make it look like the left side. So the right-hand side, we need to work on it. Everything is fine except cosecant. We change it to 1 over sine. So in fact, I want to make sure that you, instead of that, you can even write RHS for me. Again, if you were doing, let's say, exam, you could say RHS, right-hand side equals to that. That's fine, because I want you to save time. This is a complex fraction. So what is the LCD for the top and the bottom, everybody? Anyone?
It's all sine, so wouldn't it just be sine?
Just sine, that's it. You multiply the top and the bottom by sine.
Oh,
The
sine.
top becomes 1 minus sine squared, and the bottom is just sine times sine or sine squared. Now the rest is fairly simple. Does that make sense, everybody? Any questions? So it's 1 minus sine squared over sine squared. 1 minus sine squared is the same as cosine squared. And cosine squared over sine squared is the answer. And that is what? Cotangent squared. We just established the identity, everybody. That sounds good? Any questions? All right. Let's go to the next page. We want to establish the following. 1 minus cosecant theta sine cubed equals cosine squared. Again, which side is more complicated?
Left.
Clearly, the left-hand side. So all you have to do, start with the left-hand side and replace the cosecant with what? 1 over sine. So if you replace this with 1 over sine, you get 1 minus sine squared. And that, everybody knows, is cosine squared. Sounds good, everybody? So I hope you see the pattern. So what we are going to do, the same thing, we're going to pause here. I want you to do this from A to Z. I think by now you have enough. Okay, obviously the left side is more complicated. So any idea how we start this? What do we do with the left side? Anyone?
One plus tan over 1 plus 1 over 10.
Beautiful. Because we want to get to 10, let's change everything to 10. Practically, you're done. It is a complex fraction. You're going to multiply by tangent, the top and the bottom. When you multiply it by the top, you just keep it as a product. When you multiply it by the bottom, you get tan plus 1. Does that make sense, everybody? As you can see, 1 plus tan u is the same as tan u plus 1. They cancel each other. This one and this one, they cancel each other. So you're done. Sounds good? Any questions, class?
Question about A.
Yes, of course.
I was following everything up until, I understood the 1 over sine theta instead of the cosecant theta over there, but I didn't follow after that. Would you mind repeating it, please?
Okay, so let's just go back. So this is fine, right? Is this step okay?
Yeah, when you substitute 1 over sine, yes.
Then that means sine cubed over sine theta. So this portion becomes sine cubed over sine theta. Am I right?
Okay, yes. I guess, yes.
So sine cubed over sine.
Okay, yeah.
Is sine squared. And 1 minus sine squared is cosine squared. And that's the right side, and we're done.
Okay. Yeah, I see. Thank you.
My pleasure. Everybody is okay with the question and the answer, class? All right. I'm going to move on. All right. 1 over secant x plus tan x plus 1 over secant x minus tan x equals 2 secant x. All right. Clearly, the left-hand side is the more complicated side. Agreed?
Yeah.
So we are going to take a common denominator, class. That sounds good to everybody? So let's see what happens when we do that. The common denominator is secant x plus tan x times secant x minus tan x, which is secant squared minus tan squared. And so we have 1 times secant x minus tan x plus 1 times secant x plus tan x. That sounds good? So what comes next? It's very simple. When you add up the top, everything adds up. We end up with 2 secant x because negative tan x and positive tan x, they cancel each other. So you have 2 secant x divided by secant squared minus tan squared. Is everybody okay with this so far, class?
Yes.
Can anybody tell me what happens next? Anyone?
Secant square.
Any Pythagorean identity comes to mind?
Yeah, tan square plus 1 equals secant square. So all of that.
Let me just. So tan squared x plus 1 equals secant squared x. Everybody agrees with that? Yes or no? So what is secant squared minus tan squared? Anyone? What is secant squared minus tan squared? That's equal to 1. And that's equal to the right-hand side. Do we see that, everybody?
Okay.
Please tell me yes.
Yes.
Yeah.
Class, this
Mm-hmm.
results in this. Okay? I hope you're comfortable with this. I want to get the last question. Is everybody done and okay with this?
Yeah.
Excellent. All right, we want to establish this. Which side do you think we should start with?
Right hand.
The right-hand side. So we start with the right-hand side and we say cosine times tan because negative times negative is positive. Agreed?
Yes.
So what do you think we should do next? What is our next step, class? Anyone?
Should we switch the tangent?
Into, you're absolutely correct. Into what?
Or sine x or cosine x?
That's it. You're done because the cosine drops and you got the answer. And this is it. Believe it or not, this is it, class. Okay. So it's very straightforward. I hope you see that. Now, the next page, and I'm not going to go over that. I'm going to go just show you in a moment. I want you to work on this stuff on your own and see if you can do it at home. Okay. So some of them I've done the proof, but you know, the first one and the second one I want you to work on. Okay. So that's a good question to look at. at home. See if you can establish it. Those are really good ones. And if you can do them, you're in good shape. Okay, class? Now I want to pause the recording and talk about the exam and the practice test. Is everybody done? Is there any questions besides that? I'm going to go over that. Okay with what? Okay. I'm going to pause the recording, class. And this is it for tonight.